So I want to go over the problems from section 8.2 that people had questions on. So the first one is problem number 2. And in problem number 2, you have the integral from 0 to pi of 8 sine to the 4th x dx. And on the answers that I did that are posted online, I did not use a reduction formula, but I had a lot of people say that they did use a reduction formula on this problem, so I figured I would do it out that way using the reduction formula. Otherwise, you can, for the other way, you can look at my solutions. So we're going to factor out the 8, so I have 8 times the integral from 0 to pi of sine to the 4th x dx. And so we're going to come back and figure out what this is with the 8 and the limits of integration, but let's just work on the integral first, so without the limits of integration. So sine to the 4th x dx. So if I use a reduction formula, this is going to end up being negative 1/4 cosine x sine cubed x plus 3/4 the integral of sine squared x dx. And then to integrate sine squared x, we're going to have to use the half angle identity. So I have minus 1/4 cosine x sine cubed x plus 3/4 the integral 1/2. So the half angle identity is sine squared of x is 1/2 1 minus the cosine of 2x dx. So this would end up being minus 1/4 the cosine of x sine cubed x plus 3/8 times the integral of 1 minus the cosine of 2x dx. So if I integrate these, we now have 1/4 cosine x sine cubed x plus 3/8 times x minus 1/2 the sine of 2x. And then it would normally be plus c, but in our case, we are interested in 8 times this evaluated from 0 to pi. So 8, the integral from 0 to pi of the sine to the 4th x dx is going to be 8 times minus 1/4 cosine x sine cubed x plus 3/8 times x minus 1/2 sine 2x, all evaluated from 0 to pi. So we're just going to plug in. So I have minus 1/4 cosine pi sine cubed pi plus 3/8 times pi minus 1/2 sine of 2 pi minus 8 times, if I plug in 0, minus 1/4 cosine 0 sine cubed 0 plus 3/8 times 0 minus 1/2 the sine of 2 times 0. And let me slide this up here a little bit so we have some more room. Okay, so a bunch of this stuff is going to go to 0, right? So the sine of pi is 0, so that whole term is going to go to 0. The sine of 2 pi, that goes to 0. The sine of 0 goes to 0. And this part here, the sine of 0 goes to 0. And this part here also goes to 0. So what we really have left is 8 times 3/8 pi, which would end up being 3 pi. So there is another way to get that problem. It's just by using the reduction formula, and that's totally okay to do. Okay, so the next problem is problem number 3. So it asks for the integral of 16 sine squared x cosine squared x dx. And so in this case, we have, so if I have sine squared x and cosine squared x, I'm going to need to use the half angle identities to break them down. So this is going to become 16 times 1 minus the cosine of 2x over 2x times 1 plus, oops, not over 2x, over just 2, plus 1 plus the cosine of 2x over 2 dx. And so what ends up happening is this 2 cancels the 16 to get 8. This 2 cancels with the 8 to get 4. So we're left with 4, and I'm going to pull it out in front of the integral, times 1 minus cosine 2x times 1, whoops, put my guard up here, so times 1 plus the cosine of 2x dx. And to be able to integrate that, I have to multiply it out. You'll notice that it happens to be 1 minus cosine of 2x, 1 plus cosine of 2x. So when I multiply it out, we're going to get the difference of squares. So I have 4 integral of 1 minus cosine squared of 2x dx. And then I can't integrate just the cosine squared of 2x, so I have to actually break that down again. So I have 1 minus, we're going to use the half angle identity again. This time I have a 2x instead of an x, so when I use the half angle identity, I'm going to get 1 plus the cosine of 2 times 2x, which will give me 4x all over 2 dx. So this is going to be 4 integral 1 minus 1/2 plus 1/2 the cosine of 4x dx, or 4 times the integral of 1 minus 1/2 minus 1/2 cosine of 4x dx, which I'm going to come up over here, is going to be equal to 4 times the integral 1 minus 1/2 is 1/2. So I have 4 times the integral of 1/2 minus 1/2 the cosine of 4x dx. So in this case, it's going to end up being 4 times 1/2 x minus, so the 1/2 is going to stay there, and now I need to integrate the cosine of 4x. So I'm going to get a 1/4 sine of 4x plus c. So we have 4 times 1/2 x minus 1/8 the sine of 4x plus c. And then you could distribute that 4 through, so you would end up with 2x minus 1/2 the sine of 4x plus c. I know a lot of people asked me to still do number 4, and I will do it, but I want to get through all the problems that are like ones you could see first. So I will save number 4, and I will write up the solution to number 4 and post it completely separate from this video. Okay, so the next one then is problem number 5, and it asks for the integral of 8 cosine cubed 2 theta sine 2 theta d theta. And so if I look, I have an odd power of cosine and an odd power of sine. Since the amount of cosines I have is bigger, I'm going to think about breaking off the sine. And so I just have one of them, so it's going to stick around. And then I'm going to let, this is a simple u substitution problem, so we're just going to let u be equal to the cosine of 2 theta. So du is going to be equal to negative 2 sine theta, sine of 2 theta, d theta. And so you could think about it, derivative cosine is negative sine of 2 theta and then times 2. I just wrote the 2 out in front. So I need a negative 2 inside. So we're going to put a negative 2 inside. I have to balance it with a minus 1/2 outside. So now we're at minus 1/2, the integral. I'm also going to pull the 8 out in front. So minus 1/2 times 8. And then inside I have minus 2 cosine cubed 2 theta sine 2 theta d theta. And so the minus 2, the sine of 2 theta, and the d theta, all this is going to become the du. So so this is now equal to negative 4, the integral of u cubed du. So negative 4 u to the 4th over 4 plus c. So the 4's are going to cancel. So I just have minus cosine to the 4th of 2 theta plus c. So not too terribly bad. So let's look at the next one you guys asked me about, which was 6. So in 6, it's the integral from 0 to 2 pi of the square root of 1 minus cosine x over 2 dx. And so integrating it the way it is pretty hard, but we can use actually a little trick here. So x, I can really think of x as, this is really the integral from 0 to 2 pi of the square root of 1 minus the cosine of 2 times x over 2 all over 2 dx. And so all of this stuff underneath the square root sign here, it looks a lot like the double angle identity for sine squared. It's just that instead of sine squared of x, we don't have just 2x, we have 2 times x over 2. So all of this stuff is going to become the integral from 0 to 2 pi of the square root of sine squared of x over 2 dx. And then I can take the square root of the sine squared. So we have 0 to 2 pi sine of x over 2 dx. And then to integrate that, so the integral of sine of x over 2 is going to be negative. And so we're going to have the cosine of x over 2. And then I have to divide by the coefficient in front of the x, which in this case is a 1/2. So you could think of it as minus 1 over 1/2. We're evaluating that from 0 to 2 pi. So this is really minus 2 cosine x over 2, evaluated from 0 to 2 pi. So it's going to be minus 2 cosine of 2 pi over 2 minus 2 cosine of 0 over 2. So it's going to be minus 2 cosine of pi plus 2 cosine of 0. So cosine of pi is negative 1, so minus 2 times negative 1 plus 2 cosine of 0 is 1, so 2 times 1. So we're going to end up with 2 plus 2, which in this case is equal to 4. Okay, so the next one, 7, asks for the integral from minus pi over 4 to pi over 4 of the square root of 1 plus tangent squared x dx. And so remember, 1 plus tangent squared x is secant squared x. So that's going to be kind of nice. It'll help us get rid of the square root. So I have minus pi, not over 2, over 4 here. So minus pi over 4 to pi over 4 of the square root of secant squared x dx, which that would be equal to the integral from minus pi over 4 to pi over 4 of secant x dx. And then secant x is one of the ones I gave you on the sheet. So it's just the natural log, the absolute value of secant x plus tangent x, evaluated from minus pi over 4 to pi over 4. And so now all I have to do is plug in. So we have the natural log of the absolute value of secant of pi over 4 plus tangent of pi over 4 minus the natural log absolute value of the secant of minus pi over 4 plus the tangent of minus pi over 4. And so that's going to end up being the natural log. So the secant of pi over 4 is root 2. The tangent of pi over 4 is 1. So natural log absolute value of root 2 plus 1 minus natural log absolute value. The secant of minus pi over 4 is also root 2. And the secant of, the tangent of minus pi over 4 is minus 1. And so that's as far as you need to go. So I know in the solutions I took it a little bit further, but you do not need to do that. Okay, so the next one number 8 asks us for the integral of secant to the 4th theta, d theta. And so again, this is one that people ask me, well, could I use a reduction formula on it? And sure, you can. So my answer on the review sheet, I did it without using a reduction formula. So I'll do it this time using the reduction formula. So if we use the reduction formula, we end up with the secant squared theta tangent of theta divided by n minus 1, so that's going to be 4 minus 1, plus 4 minus 2 over 4 minus 1, the integral of the secant to the 4 minus 2x dx. So in this case, we're going to end up with secant squared theta tangent theta all over 3 plus 2/3 the integral of secant squared. This shouldn't have been an x, it should have been a theta, right? Theta d theta. So secant squared theta d theta, and so we have secant squared theta tangent theta all over 3 plus 2/3. So the integral of secant squared theta is tangent theta, so tangent theta plus c. So it is a little bit like shorter if you use the reduction formula, and that's totally fine. You definitely could do that. So 9 is another one that if you wanted to, you could have used a reduction formula. So for tangent cubed x dx, so I could have pulled the 4 out for tangent cubed x dx. And if you use the reduction formula, you're going to have 4 times, we're going to have tangent squared x over 2, 3 minus 1, minus the integral of tangent to the first x, because it's tangent of 3 minus 2, which is 1, so tangent x dx. So we end up with 2 tangent squared x minus 4 times the integral of tangent x. To be able to integrate tangent x, we want to think of it as sine x over cosine x dx. So we're going to have 2 tangent squared x minus, if I do here, if we let u be equal to cosine x, du is going to be minus sine x dx. So I need a negative in front here. I need another negative, which makes that a positive. So this becomes plus 4 times the integral of 1 over u du. So we have 2 tangent squared x plus 4 natural log absolute value of u plus c. So 2 tangent squared x plus 4 natural log absolute value of cosine x plus c. And so we end up actually with the with something very similar to what I have on the solution. The kind of difference is on the solution I have a secant squared x, and it's just because I didn't use the reduction formula, but these two are actually equivalent. So you could do what I did on the review sheet, or you could use the reduction formula like I did here. Okay, so the last problem, which is the last one on the sheet, 10, asks for the integral of the sine of 3x cosine of 2x dx. So those angles don't match, so we need to use a identity, and so I'm going to use the identity that the cosine of ax, or I guess I should, I was just going to do it from memory, but I should write it the way that I have it on the sheet. So we're using the identity that the sine, so we have the sine of sine of mx cosine of nx is equal to 1/2 times the sine of m minus nx plus the sine of m plus nx. Okay, So if we do that here, this is going to turn into the integral of 1/2 times the sine of 3 minus 2x plus the sine of 3 plus 2x dx. So we're going to have, I can factor the 1/2 out in front. So 1/2 the integral of the sine of x plus the sine of 5x dx. And if I integrate each of them, so I have 1/2 times the integral of sine x is minus cosine x. The integral of sine of 5x is minus 1/5 the cosine of 5x plus c. And you could leave the answer that way. You could distribute the 1/2. So minus 1/2 cosine x minus 1/10 cosine 5x plus c. So those are all the problems from 8.2.